This podcast is sponsored by GoCD, an on-premise, open-source continuous delivery server by ThoughtWorks. GoCD gives you complete control of and visibility into your deployments across multiple teams. To learn more about GoCD, visit go.cd/InfoQ for a free download.
Welcome to the InfoQ podcast. InfoQ is a site for professional software developers driving change and innovation on their teams. The InfoQ podcast is focused on discussions with architects and software leaders driving that same change at some of the world's most innovative software shops. My name is Wes Rice. I'm the chair of the International Software Conference's QCon, organized by InfoQ. Today we are having a discussion with Keith Adams. Keith is the chief architect at Slack. Prior to that, he was an engineer at Facebook, where he worked on things like the search type head backend and is well known for the hip hop VM. By the time this podcast airs, Keith will have presented at the 10th Annual QCon San Francisco, which was this past November 2016. His QCon talk was entitled How Slack Works. You'll be able to find the full video online at InfoQ, of course, within a few weeks of the conference. Keith, thanks for joining us.
Thanks, Wes. Stoked to be here.
You know, when you and I spoke before, you said a lot of people don't think of Slack in the correct problem space. What are some of the core challenges, the core problems facing Slack today?
Obviously, messaging is a space that a lot of people are exploring right now. Slack is focused on persistent group messaging, right? So messaging that sticks around, you can search, you can archive, you can derive value from the old messages. And groups, right? So potentially large collections of people who are trying to solve a task together, typically in a workplace. Most of our paying customers are employed at the same company. So in terms of what's different about that challenge versus something like, say, WhatsApp, or at least as sort of consumer-oriented messaging products are currently conceived, is large N. All right, so typically, if I'm using, say, Facebook Messenger or using WhatsApp, I can start group chats, but I start them by kind of curating the membership of that. Right, it's a little bit like email, where I have to decide who's on the to line, and that realistically limits the kind of conversations that are possible to have. I'm not going to think to add all 200 engineers at Slack, for instance, to a to-line, or exactly the 100 of them that are interested in this part of the technology stack, but not that part of the technology stack, and so on. So the kind of product-level innovation of channels, which are basically self-selected chunks of people where people curate themselves in and out of the topic instead of senders deciding who they're sending to, gives rise to this problem of having large groups of people that you need to notify in real time, keep up to date, and so on. It's a long story for sort of why I think Slack's been successful there when there have been some other places that have tried, and I think that we're doing better than. A lot of it actually has to do with the sense of presence, with the sense that a Slack channel feels like a place, feels like the water cooler, and it feels like a place that you're comfortable having a conversation in. And it turns out there's a lot of technology that kind of goes into providing that illusion effectively.
That's certainly not an accident that you have that presence, right?
Mm-hmm.
So what are some of the things from an architectural perspective that you do that make Slack feel like Slack?
Yeah, so I think the big one is partly just the slipperiness of conversation, right? So we're doing this over video conference right now, right? And we're very used to the idea in both voice and video interactions that latency basically breaks your product, right? No matter how high quality the compression is, no matter how good the actual codecs are, if there's too much twitchy back and forth even over a poor line, it's just going to feel terrible, because every time you start talking, I say, oh, well, oh no, you go ahead. Oh no, wait. Oh no, you go ahead. Those kinds of hesitations actually happen in messaging products as well, right? So you see messaging products kind of building little easements that are things that your nervous system just does for you in 3 dimensions when you're actually sharing space with people, right? So, for instance, they give you typing indicators. They give you little green dots next to usernames to tell you who's there and who isn't. But another thing that's just important is just sheer low latency. It's just the difference between 100 milliseconds and 200 milliseconds, which sometimes is the difference between sort of a conversation that feels like it flows and a conversation where there's lots of sudden stops and starts. So one of the things we do, and it looks like I hope we'll get a chance to talk about our message server architecture sometime here, but one of the things we do is just monitor ping time back and forth to the message server. If you sit there and listen to the WebSocket we open to our message server, you'll occasionally see ping pong messages going back and forth. And we use those to measure our latency out to our clients in various parts of the world. And our 90th percentile for that is well under 100 milliseconds, and we strive to keep that the case.
And so what happens when you're not hitting 90th percentile? What type of I guess, logic do you have to kind of resolve that?
Yeah, so we most of our efforts for people who are there's a couple of reasons you might be, if we're not hitting 100 milliseconds consistently, the odds are good that we've got a software problem, right? So that might mean profiling our message server. That might mean finding out, oh, we added memory allocations here or something, so the GC is kicking in. It is a Java software. A lot of times it's just network conditions,
Okay.
right? So arguably all mobile clients, right, all mobile devices are, in a sort of degraded or about to be degraded condition all the time. And the argument for that is, even if you've got, nice solid 4 bars of 4G, there's really no way for the product to know that you're not, heading into the subway tube right this second. And so most of the kind of really bad jitters ends up being due to network conditions that we've been able to determine so far. So there's a limited amount of stuff that we can do about that. And then what I just said about sort of low latency and feeling buttery smooth and stuff, we kind of try to gracefully degrade as much as we can, and all the way down to, in a perfect world, all the way down to email or something, right? Where really it's just bulk synchronous. But of course, we're not all the way there yet. I think from a product point of view, the disconnected experience of the mobile clients is one of the things we've just got a bunch of work to do. And there's some systems work there too. Part of that's going to be buffering and caching and having a good guess of what stuff you're likely to want to see when the network is intermittently available and we are able to get a few packets down. So it's a little bit of a mixed bag. It depends where the latency problem's coming from.
What about issues, say, with like large teams? Any issues there?
This is arguably controversial, but I believe that's a thing of the past. We have, many teams that are sort of well into the thousands and low tens of thousands now. And our telemetry and user reports and the sort of volume of customer tickets we get and everything suggests that they're having a pretty good experience. Hopefully getting resolved.
So what are you seeing as like your largest teams inside Slack today?
Oh, we're seeing teams larger than 10,000 now.
Wow, that's really cool. So let's talk about the architecture that supports that. You talked about messaging server earlier, and I know from some of the reading that you've got a lamp stack to some degree, right? So what's that architecture look like?
Yeah, so there's a whole big chunk of the Slack architecture on the back end that you can almost just label, sharded lamp stack, right? You can almost just label it mentally. This is, a bunch of stateless web servers, some memcache, and then a fleet of MySql machines. And that fleet of MySql machines currently is sharded by team. So your team essentially hashes down to sort of some pair of replicated MySql machines. We have a big PHP application with a bunch of application logic in it. And there's a table that represents the channels and a table that represents the users and relatively normalized schema that represents the whole product. So that part of it is the kind of thing that you could, hold your breath and write with your spinal column. You'd have written Slack 1.0 if you knew exactly what to build for that part of it, where it's just, people, their profile pictures, their email addresses, the names of channels, the who's in the channel and all that stuff.
Sure.
That all more or less works how you imagine if you kind of just close your eyes and guess how it would work. The part of Slack that's new is client-server interaction, and specifically the real-time part of it. Right? So a big chunk of what makes Slack feel like Slack, in my opinion, is our messaging infrastructure. So, Slack is a write amplifier, right? Slack is a thing that takes the message that you sent and broadcasts it, hopefully in a low latency, reliable fashion, to all the people that want to see this message that you've sent. And we just talked a little bit about how latency is important there. We are, I think, one of the largest WebSocket users on Earth. We just hit a new record for peak WebSocket connections. I think I'm not allowed to say what the number is, but it's a big number. And it turns out that's a little bit unusual. We actually do have people, since a lot of our users are using us from desktops and they might be on, office Wi-Fi or wired Ethernet, those are actually truly long-lived connections. There's actually not a gigantic amount of the infrastructure and sort of scale-out wisdom that you hear these days is implicitly request-based. And actually having really long-lived connections that are sort of expensive to destroy and reestablish breaks the model of how you scale out a lot of things.
I've got a question there. When you say a lot of the conventional wisdom around scale is request-based, how's that different for Slack? What type of problems are you facing that are different?
Well, I mean, there's an assumption that if you sort of swing traffic away from a box, that in a boundable amount of time, I can actually take the box out of production, throw it away, updated software, do whatever I need to do, put something back in its place, and that eventually new traffic will flow into that thing. And that all can happen in the scale of sort of seconds or minutes or something, not hours and days. And That's not necessarily true for us right now, right? So we can take down a message server box, but when we do that, potentially thousands of users are affected, right? They all need to reconnect to Slack. We're getting better at this all the time, and I think the experience is a lot better now than it was at the beginning of the year, but it still isn't free. It's still like a user perceivable kind of bubble of the sort that I was just saying ruins the illusion of presence for people. So we're not as able as you are in, say, a web tier, right? With a web tier, it's really, cattle, not pets, right? You just absolutely don't care which machine happens to handle the request as long as it's running the right version of the code. With the web server, there really is kind of non-trivial shared state between the client and the server, or with the message server, rather. There's kind of non-trivial shared state, which is just the TCP connection, right? Just the two ends of the socket there. We're at early days with this right now, right? One of the things we've written actually a blog post about this, where we talked about a system called SlackD, which is an application-aware edge cache. So you asked before about users that are getting a terrible latency experience, right? Well, a lot of those users are actually somewhere that's just geographically far from where our central data center is. We're on the East Coast of the United States for most of our server-side infrastructure. And if you're doing round trips back to the East Coast of the United States from, say, India, right, it's very hard to get it 100 milliseconds all the time.
Sure.
And so we are starting to terminate those WebSockets with a application-aware edge cache that we were calling SlackD earlier in the year. We're calling it Flannel now. The project kind of actually got rebooted. We're calling it Flannel. And this is like us first code change. We don't have it in front of our internal team, so Slack, which is tinyspec.slack.com, because Slack used to be the company known as TinySpec. Our internal Slack team is using Flannel currently, so all umpteen hundred, however many hundred employees there are using it, and it seems to work and seems to be effective at this task of kind of making the round trip time be much more tolerable. You still have, to be clear, there are speed of light problems, right? If you really are having a back and forth to somebody on the west coast of California or something, we can't get the bytes back and forth any faster, and you do still have those stops and starts. But if you're having a local conversation, but it just so happens that a person you're having a local conversation with is close to you but far from Slack, it no longer has to be the case necessarily that you're going halfway around the world to get your messages.
So when messages are sent in, what does that look like? How do you persist, and how do those messages flow through the system?
Right. So imagine you hit send on your favorite client device. Your typical Slack session has kind of two interactions with the Slack backend. One is interacting with that LAMP stack I just described, and it's doing that over a RESTful API, and it's the set of APIs that are documented api.slack.com. The same sorts of methods you'd expect. That's actually not how we send messages. You're probably expecting us to say that you post to a message post method. There is such a method in the API, and it does work, and you're welcome to use it. But typical clients actually do a write up the WebSocket that they have to the real-time messaging system, and so they encode it in JSON. They send it up the real-time messaging stream. It makes its way through the internet. It gets decompressed. SSL gets terminated. All kinds of things happen in the cloud, and it ends up on the other end in memory in this Java process. And so this Java process decodes the JSON. It does its write amplification, right? So it actually, does and that is literally a for loop, right? So that part of our infrastructure is also team sharded currently. So we're running a plurality of message servers. Everybody on your team, as I sit here talking to you, is on the same message server. Watch this space, of course. So that thing literally goes over a for loop for all of the other people that are currently logged in on your team, and tries to deliver the message to them best effort real time. And that's very close to kind of the speed of light, right? You could basically get the JSON up into Java, read what it says, send it down to everybody else that's in the channel that's actually connected. And in parallel with that, you start doing a sort of side request over to the LAMP stack. So it actually does a callback over into the PHP code base to basically say, hey, this message happened, you need to persist it. And we do those in parallel with sending them down the wire. This is one of the things that sort of is a little bit, to some extent, feels different than user expectations. There's a convoluted enough series of failures where a message really is ephemeral even though you saw it. Right? So the convoluted enough series of failures would be, that I do a send up this WebSocket, the message server broadcasts it to some of my coworkers, they see it, and it says, attack at dawn or something. And they read, okay, attack at dawn. And in the process of it talking to the web stack, it dies, or the web box it's talking to happens to die, or something like that. And lo and behold, we've shown people this thing that, if you go back and reload the channel, isn't there, because from the point of view of MySQL, it never happened. To the extent that we're able to measure these things, we think that we're not sure it's ever happened. But it is a physical possibility with the architecture right now, and we're talking about ways we're in the process, kind of hinted at not being completely pleased with team sharding this chunk of the infrastructure. My hope is that this is one of the things that goes away with the redesign of this that we're undertaking currently. So the message server is a bunch of Java code that a founder of Slack, Sergey Morachev, wrote and maintains and helps operate, and he's kind of a one-man army over in Vancouver working on this stuff. He's recently gotten a bunch of help and is busy beavering away on a system that we call MS 2.0. It's going to be a drop-in replacement. It has the same functionality I'm describing. It's still going to be the thing that terminates WebSockets, but has a bunch of sort of things that we now feel are learnings from the product, that from having operated it for a couple of years and having seen how people use it, having thought about some of the edge cases and failure cases in the current system, that hopefully will make it better. And this persistence hole is sort of still on the table for whether that's going to be one of the things that we fix or not, because the evidence is that this isn't actually biting people.
Yeah, so a bunch of questions come up to me. So first off, you may not even be able to answer this, but all these shards, what are we talking about with Slack? What kind of volume of servers are out there?
So I have to be, we're a private company, and I have to be careful with sort of anything that you can turn into kind of CapEx or whatever. But it's more than hundreds and fewer than hundreds of thousands of servers, right? So it's a lot of servers. It's enough that you don't want to treat them like individual machines with personalities and characteristics and hopes and dreams and stuff. You really do want to be able to treat them like commodities.
Okay, so but what about the back end? You talk about these shards. Are these things all fully isolated? I mean, there's no common back end, no common event store or anything like that has all these messages flowing through?
Yeah, one of the things that surprised me kind of coming on board was that I half expected there to be some kind of framework that that there's some story like Elixir or Erlang or Kafka or something that wires this all together. That's really not the case, right? This is kind of like we make software the old-fashioned way, we write it for the most part.
Yeah, that's kind of what I was expecting. I was expecting to kind of hear a kind of a Kafka backend and how things were being sent out to individual teams. But so it's actually the shard of the actual MySQL database, and the full team is actually living on those, or the full conversation of that team is living on that shard.
Yeah, that's correct.
Interesting.
And just kind of diving into that a little bit in terms of sort of why that is. Slack has kind of a culture and a technical personality. And that technical personality, which I find appealing because it aligns with my personality, is pretty conservative. And it's not that we're against taking risks. We'd like to take risks where it makes sense to take risks. And actually, in service of moving faster is a perfectly good place to take risks sometimes. But taking risks in terms of the technology stack and having a kind of black box that you can't quite fit to your use case is a really frustrating situation to find yourself in. And by the way, we use stuff, right? I mean, one of the reasons Kafka is on my lips is that we do use Kafka. Our logging infrastructure does go through Kafka. Our data warehouse is fed by Kafka. It is sort of the big funnel that a lot of our other sort of logging systems end up feeding into. But in terms of actually getting messages from user to user or from user into persistence, that's all too sensitive, we feel, to kind of pull something off the shelf. At least we couldn't find the right thing to pull off the shelf that would do exactly what we wanted to do, and we felt we knew how to write exactly what we wanted to write.
Well, that explanation kind of speaks to one of the very few complaints that I've heard about Slack, and that kind of has to do with this whole idea of you have a different logon for every team. In my Slack client, I probably have 12 different organizations that I'm a part of,
right,
and everyone has a different logon. So it kind of makes sense given what you just described, because it's completely sharded and segmented based on the team, right?
Yeah, and I think that's an interesting point. I think the model with the interaction that Slack has with users is sort of different than the interaction that consumer internet sites usually have with users, in that when you go to Facebook or you go to Twitter or you go to Google, you have a relationship to Facebook and a relationship to Twitter and a relationship to Google. Whereas the way that Slack sees itself sort of fitting into the world is that there are organizations that have relationships to us, and then you as an individual have relationships to those organizations. So, you can almost think of creating a Slack team as sort of instancing Slack. Like, in a way, it's sort of getting your own little copy of it that you get to run, and you get to invite who you want to. Now, if you're a business user, this is actually really important to you because you want to very carefully control exactly who has access to the system exactly when.
Right.
So, for instance, if I'm, some large business, I probably want to have a process around how I, revoke your Slack credentials, say when you get fired,
right,
or when you leave. The most direct way to kind of give things like business customers, their own SSO system, control over their sign-on procedures, control over what devices end users are able to use with Slack, and so on, is to basically give you your own login for work, right?
Yeah.
Now, I, like you, have a whole bunch of Slacks that I'm involved in, right? I've got one that we use to run the household. I've got one for the band I'm in.
Yep.
And lots of people are in that boat. And it's true. It's like kind of a crazy experience logging in each time. We are trying to figure out how to make that better without sort of breaking the core use case of, hey, my employer controls my access to Slack, right? So I don't know if that answers your question or not. It's kind of a little bit of above my pay grade because it's kind of a product question. So this is really up to Stuart.
Yeah, absolutely. No, I understand. So let's jump back into the architecture just a second. Sorry, I kind of went off on the logon part.
Yeah, no worries.
But one of the things that I find really interesting is that MySql backend, and one of the things that I think you and I talked about before was the statement-based replication that you use in a kind of active-active scenario with MySql. Can you talk to that a bit about why you choose SBR and how that kind of works for you?
Yeah, well, so diving right into
just straight into it.
Right? I was expecting like why MySql, why not NoSQL or whatever. Well, okay, so why MySQL? Why SBR is one of the reasons for why MySQL, right? MySQL has sort of rich options for replication. A lot is known about how you operate it. Places like Facebook, and to some extent, though they don't talk about it as much, Google, have many, many, many thousands of server years of operation of MySQL behind them without losing data due to MySQL. And there's not a lot of other data storage systems that can kind of compare that level of feature richness, depth of ecosystem, and just sheer stability. Our users only care that persistence works. They don't care that we're using the edgiest persistence system possible, right? They care that it works really well, that we don't lose their data, and that they, get the semantics they expect from using their storage system. Now, interestingly, we use MySQL as a base, right? Our data, our application is actually structured around tabular data, and we think about foreign keys and everything, and use secondary indices and do complicated queries and all this stuff that sort of isn't very fashionable to do on your database these days. And yet, one of the things that we're willing to relax on with MySQL is ACID. So we have found a way to use MySQL as essentially an eventually inconsistent distributed database. And we're doing it through the magic of what we call master-master replication. And usually when you say it, people are so used to hearing MSR that sort of saying MMR, initially they think you've misspoken. We mean it. There are actually two write heads sitting there for each shard, and the write heads are sending bin logs to each other in real time. So when you do a write to one of those heads, it asynchronously writes the statement to the bin log and does the write locally and gets on with its life. It is possible for you to then do a read from the other head and see stale data, not see what you wrote. So there is a best effort attempt that we make to give you read what you wrote semantics, and that best effort is basically the low order bit of your team ID is a preference for the left or right head. Right? So if you are in an even team, we'll prefer the left head. Say if you're in an odd team, we'll prefer the right head. So most of the time you read what you wrote just because you're looking at the same set of data. That also has the nice property of, in practice, getting rid of a lot of the sources of inconsistency because most of the rows are, it's very rare that there's any actual data that's shared across teams. That's mostly metadata, not data. So you got a bunch of writes flowing in for the yellow team over here and a bunch of writes flowing in for the green colored teams over here, and then sending the bin logs back and forth to each other. You get hopefully very few conflicts, but it's not going to be zero. The attempt, so, in terms of sort of CAP theorem terms, we're choosing availability instead of consistency. Right. So if we're not able to connect to our favored side of the pair, we will connect to the disfavored side of the pair and take the chance that we don't read what we wrote, and also take the chance of writing something conflicting. Now, in terms of the odds of writing something conflicting, a lot of those row updates for us are insert on duplicate key updates. So it's like a relatively obscure kind of query, but it lets you use MySql as a key value store, essentially. So if you've got a column that you're using as the primary key of this thing, and you do writes with insert on duplicate key update, you're kind of going to do, basically you're going to overwrite the row if it's there, and if it's not there, you're going to insert it. It's not an error either way. And if you've got kind of racy insert on duplicate key updates from both heads coming in, you might see A then B, and A wins over here and B wins over here. And now you've got an inconsistency. So we are, in an asynchronous way, tailing, looking for these inconsistencies and fixing the ones that can be fixed automatically. But it's not going to be, some of these statements include things like the database's source of time, or, an auto increment or something like that. So some of these rows are actually going to be different. And it is a query by query case as you sit there as an application developer, whether a given mutation is sort of safe to this kind of environment.
Yeah.
So in our current environment, the ideal is supposed to be that, an app developer sitting there writing PHP, composing a query that mutates stuff, is supposed to be aware of and kind of think through this case. In practice, do they all the time? No, they don't. And in fact, this week we've had like a higher volume of these inconsistencies that require manual resolution, in part because of what we think is an application error. So what we have here is a kind of very, is we've chosen a storage system that works very well for the purpose we've applied it to. It's very good at sort of holding the bits that we put into it. We have chosen, for the purposes of availability, to relax some of the constraints that storage system could offer us. Why does this work? Right, so why does this end up working in practice? I think this ends up working in practice because the vast majority of mutations that happen in a system like Slack, and I think this is true of a lot of systems that are basically user-facing, are being performed at human scale and human pace. So the odds that I change my profile picture and, enough milliseconds, a small number of milliseconds later, change my profile picture yet again, in such a way that, the left side thinks my profile picture is A and the right side thinks my profile picture is B. Right. And now forever and ever, it's a roll of the dice whether you see profile picture A or profile picture B. Those kinds of scenarios are just extremely, extremely rare. And even if it really happened, I'm just going to go riff on this profile picture example for a while. Even if it really, really happened and I really cared about it, the vast majority of the time in normal circumstances, I'm always going to be looking at one head or the other. And so I might feel to me every once in a blue moon when I do that, twice back to back, and it happens, the bin log race happens in such a way that it's actually inconsistent across the two of those, which is incredibly unusual. People will fix their profile picture some of the time. Now, and I should also say, so that's what I mean about eventual inconsistency. There is some non-zero rate of these, and if we never intervened, those heads would actually diverge in ways that are hard to reason about. So we have this little recipe that we perform every once in a while where we only let the database heads live for a month, and basically every once in a while we hang new read replicas off of them, let the read replicas catch up, carefully start moving the read and write traffic around the ring that we've created. Right now there's 4 of them. So we start moving the read-write traffic around until all the read and write traffic is on the new ones. And at that time, when we turn on write traffic to those 2 new ones, we know that they're actually kind of MD5 sum the same bits.
Now I got to ask the question that you were expecting to kind of start this one. And that's, with these multiple heads that you've got going on using SBR to get availability, why not use something, NoSQL database solution like Cassandra or something like that?
Sure.
Why stick with MySQL? Eventual consistency isn't really its core strength, I guess.
Yep. This is, I think the short answer here is that this is what has worked so far and is what people have operational experience with so far. I actually think you're right that, and by the way, I should add, SQL itself is actually valuable, right? The sort of discipline of actually modeling your data and having schemas and deciding what should be indexed and what shouldn't be and how you evolve your schema and stuff like that, having design discussions around schema changes, that's actually something we lose moving to a lot of these NoSQL systems. So it's funny, if I think in practice, a lot of times people start talking about the sort of cap theorem trade-offs immediately with the NoSQL databases. It's like, well, what about the fact that I have to write the join myself by hand and have to optimize it by hand, right? I mean, what about that? So the fact that sort of we actually have a query engine there and that you can refer to the data in a structured way, and also to some extent that like operators and people looking at customer issues can actually go look at the ground truth with, the hoary collection of tools that have developed over the literally decades now for dealing with MySQL, has some value. But also this architecture I'm describing, I don't think it's the final way the data will be stored at Slack. So we started talking about a different system recently. We are still kicking the tires on sort of multiple different storage systems, but one of the properties we'd like for it to have is that there's less of a kind of direct knowledge of the business object team that sort of shapes the whole geometry of the backend. That's proven to be problematic in certain ways. And we also want it to be, in a perfect world, we'd also still like to get structured queries. In a perfect world, we'd still like to be able to talk to it in terms of SQL and use relational kind of tabular ways of thinking about the data. It's not, there are a few systems that kind of offer this out there. We're still in kind of build buy mode with that, but watch that space. And by the way, I think this is one of those things where this is a fun thing to talk about in a way because it's sort of unexpected. It's just really weird. It's kind of quirky, right? It's not your everyday thing that you're kind of sitting there, sharding by team, and then there's this master-master pair, and there's this funny dance for how you get them consistent again and everything. And I enjoy kind of talking about it because it's, just an interesting little thing that's a little bit different from everybody else's stuff. But none of this stuff is, all this stuff is means to an end, and the means to an end is kind of, delivering a service users love. So to the extent that any of this stuff is in the way, and this is, everything's kind of a little bit in the way as you scale up 10x and 100x and 1000x, I'm sure we'll end up throwing it all out and rewriting it all, 2 or 3 times if we're successful.
I was going to say, because this architecture is obviously working because everybody loves Slack. It's the fastest growing messaging tool that I've used in my development experience. People truly love working with Slack. So you're obviously doing something right.
I sure hope so. Thank you so much.
So one of the things you mentioned a little earlier as we were talking was TinySpec. And there's an interesting story that I think you told me when we were first chatting about this, about kind of how Slack came to be.
Yeah.
Could you kind of talk about that, kind of the origins of Slack and how it became this messaging system that we know and love?
It's funny. I'm actually in our little game room here trying to do this just because it was a door I could shut. I'm here at Slack HQ, and there's this some glitch artwork on the board still right over here. So the company that eventually became Slack was born as I believe TinySpec was the name of the company, and they're making a massively multiplayer game. It's called Glitch. And this is, they've built it, employed tens of people, launched it, had, I believe, tens of thousands of users, had lots of users. And this is all long before I was here, by the way, so this is, a third-person story I'm telling. And just weren't getting the traction that they were looking for, that their investors were hoping for, and were kind of in the process of turning around the open sign and saying, well, okay, so what's salvageable here, right? What have we built that might be interesting? And one of the things that engineering had built that everybody found interesting was they'd added this little daemon to the IRC server. They'd added, I think it was originally a bot actually, that just indexed the content of everything that was said, right? So this just solved the problem that if you, closed your laptop and went home for the evening and drove home, you could catch up on, whatever had happened for the last hour in the channel. And you could search it. And they started making kind of a slightly nicer skin for it. And there was a general consensus. So one of the things that was unusual was that people who weren't sort of Unix geeks were actually using this kind of souped up IRC, right? So normal human beings, if you will, were using this IRC server because it was kind of, had enough added value to be useful to them. And everybody felt like they couldn't live without it. Everybody felt like, if they weren't able to kind of make something work out of this place, this would be the first thing they'd write at whatever their new company ended up being, is they'd just go build this and try to get everybody to use it. And so they kind of went back to their investors and said, well, we've got this idea. I think relatively early on, Stuart came up with the name Slack and then eventually came up with the backronym, which was searchable linked archive of company knowledge or something like that. But I think just the name Slack preceded that actually. And people usually tell this as just kind of a shaggy dog story. It's just kind of like, hey, isn't this wacky? It turns out, this thing that's business software used to be a game company. But, I've talked a little bit about Sergey's message server, and that message server was originally also, doing presence and doing, game players moving around and so on. in Glitch, right? It used to be a game server. It actually used to be the thing that populated the world with characters that you're connected to. And I think there's actually something.
It's the world shard.
Yeah.
Yeah, I totally see it.
And I think there's actually something deep about that. I think there's actually the sort of architecture of presence, and not just, when people say presence in messaging, usually they just mean like the green dots next to people's names for who's away and who's idle or whatever. I mean presence in sort of the VR sense almost, right? Like presence in the sense of like immersion, interactivity, losing yourself in the medium, feeling like you're actually in a real place. I actually think that that's part of the ingredient of making a successful group messaging product. This is like, we don't have any science to prove that, and I'm just, a guy just talking here. But I think that's one of the reasons that this particular history was what was required to kind of make a hit in this space.
Yeah, I totally can see it. I can understand the relationship to it, and I can totally see the connection to it. So that makes total sense to me. I think it's really super interesting.
Yeah, it's kind of funny how things work out, right?
Absolutely. So we've been talking with Keith Adams about the architecture of Slack. If you want to hear more about the architecture of one of the world's most popular group messaging platforms, make sure to take a look at Keith's presentation from QCon San Francisco on InfoQ.com. Keith, thank you so much for taking the time to join the InfoQ podcast.
Thanks, Wes. Have a great one.